Section 4.4 is using congruent triangles, so CPCTC. So I've kind of mentioned this a little bit. If you watched the video yesterday, I kind of mentioned it, and previously in class, I kind of mentioned this as well. So it says, how can I prove that angle PQS is congruent to RQS in the diagram on the right? So what you would end up doing is you would say that QS is congruent to itself. So QS is congruent to QS by the reflexive property. Or you could say same segment. And then you could say that the two triangles, so the left triangle and the right triangle, are congruent to each other. So you could say, okay, well, triangle PQS has to be congruent to triangle RQS by side, side, side. Okay, so then once you know that triangles are congruent, you can say all of their pieces are congruent to all of the pieces in the other triangle. Okay, so that means that this angle right here has to be congruent to this angle right here. This one right here has to be congruent to this one right here. And then this one down here has to be congruent to this one down here. Okay, so looking at what we wanted PQS and RQS. Those are the ones that I marked in blue. Okay, so we know that angle PQS has to be congruent to angle RQS because we have congruent shapes, right? We have congruent triangles. So once you have congruent triangles, you can say all of those pieces match up. Because we have congruent triangles. Okay, so the reason that we put for this is something new, and it's CPCTC. Okay, so every geometry student has trouble remembering the letters. They're like CCP. CT, right? So it stands for something, so we need to know what this stands for. Okay, so it stands for corresponding parts of congruent triangles are congruent, okay? So if you have congruent triangles, then all of their corresponding pieces have to be congruent to one another. Does this make sense? Okay, so I want everybody to say this out loud. All right, 1, 2, 3. Corresponding parts of congruent triangles are congruent. And now you're going to do it 2 more times. So, corresponding parts of congruent triangles are congruent. Go.
Corresponding parts of triangles are congruent.
And one last time.
Corresponding parts of congruent triangles are congruent.
Okay, you need to know that for your quiz later today. So can you memorize that in the next 2 hours? You're good. CPCTC means corresponding parts of congruent triangles are congruent. So there is a song. I am a terrible, terrible singer, but I'll let you know the basic words to the song. So do you guys all know Farmer and the Dell? Get the tune in your head. You guys know that? No. My singing probably didn't help. Okay, so CPCTC. We go CPCTC, I can't do it. CPCTC, corresponding parts of congruent triangles are congruent. So it goes kind of fast, but I'm not going to actually sing that to the tune, but it goes like that. All right, I used to make my geometry students sing that. I will not make you get in the front of the class and sing it. All right, so given, so A is the midpoint of MT. So what do I draw when I say that A is the midpoint of MT? So what kind of things am I going to draw in this picture? And where will I put them? What 2 pieces have to be the same? Yeah, Roman. So A is the midpoint of this. Okay, these 2 angles will be congruent. That's by vertical angles, though. So if I'm using the midpoint thing, what do I draw? I draw a little mark there and a little mark there, because midpoint means it's directly in between. It's halfway in between, so those 2 sides have to be congruent. Okay, so as we say something, so as I say, like given, A is the midpoint of MT, we start drawing things in. All right, and then it says A is the midpoint of SR. So here's our SR. So we're going to draw 2 marks here, like that. Okay, now Roman's also noticing that we have angles that are congruent. So what angles do we have? RAT and SAM. Okay, so let's start writing everything down. So we have all the statements, luckily. So we just have to give all the reasons. So the first one, what's the first one going to be? Given, yay. All right, and then we know that MA is congruent to TA and SA is congruent to RA. Why did we know that we could draw those tick marks in? Because we used the word So we're going to say definition of midpoint. So a midpoint breaks it into two equal pieces. Then we're going to say MAS is congruent to TAR, and that's going to be Y. Could I draw those blue marks in? Vertical angles. So a lot of geometry teachers make you write out vertical angles are congruent, but I'll just say vertical angles. Okay, so why are triangles MAS and TAR, why are they congruent to each other? SAS, perfect. Okay, so now that we have that, we can say lots of different things about this shape. So we could go into lots of detail. We could say, okay, this angle M has to be congruent to this angle T, right? And then we could say that S has to be congruent to R. We can do all of those different things. So the one I'm asking for next is that M and T are congruent to each other. So why are M and T congruent to each other? Do you guys remember the letters? No, CPCTC, corresponding parts of congruent triangles are congruent. But I heard one of you guys say alternate interior angles, and that's actually the next one. So it says, well, why are these lines parallel to each other? So if we draw these lines in, and we had those angles, those lines here must be parallel to each other because we have alternate interior angles are congruent. So this is called the alternate interior angles converse. Okay, if you don't put converse, that's fine. If you just wrote alternate interior angles, I'll know what you mean. Okay. Do we feel okay about that? I know proofs are weird at first. You only do proofs for the first semester. So we got one more week of proofs. Can we handle one more week of proofs? All right, if you're given that HJ is parallel to LK, so let's draw some pictures in. So HJ and LK are parallel. And we know JK, so now I'm going to use two marks like that, two little angle things like that, to mean that these are different parallel lines. Those two are parallel as well. Use a paragraph proof to show that LHJ is congruent to JKL. Okay, so whenever you have parallel lines, you're usually using alternate interior angles on these. Okay, so we got to find where those alternate interior angles are. So look for the Z shape that I told you about. So you can extend your lines if you need to. When I was in geometry, I always had to extend things. So if you need to extend it to see it, that's fine. Do you see the Z that's created? So it's going to be this angle in here and this angle in here. Okay, so you don't have to write the given part for the paragraph proof. We had that. So let's say angle JHK is congruent to angle LKH. And now we're going to use the second parallel lines. So I have the magic eraser here. I can just erase it. You guys don't have that luxury. Let's kind of go back to where we were, and I'm going to extend the other lines so you guys can see those ones. So if I extend these, and then I have a transversal, here's my transversal. Do you see the Z shape? So our Z shape is here. So our angles are going to be here and here. So we already had these two marked in previously. Now we have these other two angles. So we're going to say, and also, angle LHK is congruent to angle JK, wait, hang on, LHK, yeah, JKH. And both of these were by alternate interior angles. Okay, so we have several things drawn in these triangles. We're trying to get to this bottom triangle is congruent to the top triangle. We always need at least one side. So right now we have two angles. We could say those third angles are congruent by the third angles theorem, right? But that doesn't help us. Did you guys understand what I was saying in the video when I was saying, oh, you know, just because you have three sets of angles congruent doesn't mean a triangle is congruent? Like think about even like an equilateral triangle. Right, maybe I have sides 7, 7, and 7. All of these angles would be 60, 60, and 60, right? But if I had a smaller equilateral triangle that was like 2, 2, and 2, these angles are still 60, 60, and 60. So if I have 3 angles congruent in a triangle, I can't necessarily say that the triangles are exactly the same size. They can't fit one on top of the other. Do you understand that? Okay, so even if I said by the third angles theorem that this angle and this angle are congruent, that's not getting me anywhere. It's not saying that the triangles are congruent. So what's my last step to say that those triangles are congruent? Yeah. Yeah, so let's say that HK is congruent to itself, right? And you can go, I've talked to one of my friends about this because I wanted to make sure. Hang on, LHJ. LHJ. What am I doing? These aren't the right, my right letters here. I'm trying to prove that triangle LHK is congruent to triangle LHK JKH. So I talked to a friend of mine the other day, and I was like, I was second guessing myself about HK and KJ. Like, technically, I would write it in that order. Like, I would say HK is congruent to KH. But he says it's fine. You can just say HK is congruent to HK and just say reflexive property. Of congruence. So by the reflexive property of congruence. Because really the symmetric property, that's what I was calling it in that video, the last video. So maybe we can correct that in the notes in a second. The symmetric property is when you have like AB is congruent to CD, means that CD is congruent to AB. So I started second guessing myself and I was like, wait a second, that's not really what the symmetric property is. I don't mean for it to be like AB is congruent to BA. That's not the symmetric property. That would still be the reflexive property actually, because it's exactly the same segment. Does that make sense? Do you guys understand what I'm saying? So if you feel more comfortable just saying same segment, that's fine with me. But it should technically be the reflexive property. Okay, so anyway, so we have the reflexive property of congruence. So now we can say those triangles are congruent. So we can say LHK. Oh wait, did I have angles? No, I didn't have angles. Maybe that's what I wanted. I wanted angles in there. LHJ. No, I don't think I did. We'll still keep it that. So LHK is congruent to triangle JKH. By angle, side, angle, right? Do you see that? So now you can prove anything about those two triangles. So if I wanted that angle down here, angle L, to be congruent to angle J, could I then say like those two angles are congruent? Yeah, so then I could use CPCTC to say any other thing is congruent there. I think I wanted it to be a CPCTC, but that's okay. So we'll do this next one. So MP bisects LMN. So MP bisects LMN. So we have these two are congruent. And then LM is congruent to NM. So those two are congruent to each other. Are you guys seeing how we're going to get the triangles congruent to each other? Okay, what's one last side that I'll need in order to say congruent? Yeah, exactly, the reflexive property again, right? So we're going to say MP bisects, that was given to us. And when we knew that it bisected, we were able to draw in those angle marks. So we could say that LMP, so angle LMP, is congruent to NMP. And the reason is because we had an angle bisector. So definition of angle bisector. MP is congruent to itself because we have the reflexive property, or you could say same segment. LM is congruent to NM, was given to us. So we can then say our triangles, so I'll say LMP is congruent to triangle NMP by side angle side. We're trying to prove that LP is congruent to NP. So let's look for them. LP and NP, would those have to be congruent now? Sure, and that would be that by the CPCTC. Okay, so are you seeing how this is working? These are probably the most common proofs in geometry. The ones where you get triangles congruent and then you use CPCTC. Okay, so this next one. So we have JK is congruent to QP. That was given to us. Same thing, JK is parallel to QP. That was also given. You could put that in one step if you want to, not two. we have those markings drawn in. We want to prove that KQ bisects JP. So basically we want to prove that these two right here are congruent. Okay. So let's start with our parallel lines. So when we have parallel lines, we're always looking for those alternate interior angles. So we have our Z shape right here. Do you guys see it? So it's here and here. So we're going to say that angle J is congruent to angle P by alternate interior angles. We also have another Z shape. Do you guys see the other Z shape? If we use this other line as our transversal, it's right here. So this one and this one are congruent as well. So we're going to say angle K is congruent to angle Q. That's also by alternate interior angles. Okay. So were any of you guys thinking about doing something different? You didn't have to do those two angles. We could have done something different. We could have also done what angles? The vertical angles, right? Does that make sense? So this is what I was saying a couple days ago. Like, your proof might be different than your friend's proof. Okay, that's what can be frustrating for students with proofs, because they think there's only one way to do them. Okay, there's other ways to do these. Okay, so maybe you had those vertical angles. If you had the vertical angles, your reason would be angle, angle, side going around. Okay, but I didn't do vertical angles. I did alternate interior angles. What's my reason for these two things going to be, two triangles congruent? Do you guys see it? Why can I say the triangles are congruent? By angle, side, angle. Okay, so yours might be different than your friends. Okay, so I have triangle. What's my first triangle? So I have triangle JKM is congruent to, so I went 1 mark, 2 marks, no marks. So I want to go 1 mark, 2 marks, no marks. So I want to say PQM. And that was by angle, side, angle. We're trying to get to the point where we say that KQ bisects JP, so we want this to be congruent to this next. So we're going to say that JM is congruent to first and second letter, so PM. That was by CPCTC. And then the last step, KQ bisects JP. So what do you think we're going to put for our reason? Sarkis, you with me? So reason, what do I put? Do you guys have it? Definition of what? Close. He said angle bisector. What do you think? Segment bisector, yeah. So definition of segment bisector, because it was a segment that was being bisected, right? Okay. That's about as hard as they get. Okay. So let's stop